Although you may not always notice them, trees are a huge part of what makes the University of Richmond so beautiful. Trees provide shade when you're studying outside and are very important to landscaping aesthetics. We all see them every day, but how much do you know about them? A project to map all the trees on campus is working to provide the University of Richmond community with information not only on what kinds of trees are on campus, but also what kind of benefits they bring to the local environment through ecosystem services like carbon sequestration. Countless students from geography, environmental studies, and biology labs, and students doing independent studies have contributed to this project since 2012, recording 2,261 trees on campus, analyzing data, and gaining a deeper understanding of our local ecosystem. To collect data, we use an app called ArcGIS Collector. Here, we can view a web map of all existing points to update the information of a tree that's already been collected, or to create a new point. For each observation, we record who is collecting the data, the date, the name of the species, if the tree is alive, dead, or missing, the height, and the diameter at breast height. We use dichotomous keys and field guides to identify the species using traits like leaf size and shape, bark color, and the presence of seeds or flowers. Diameter at breast height, or DBH, is a very common measurement used in forestry. We measure the DBH with special measuring tapes that are scaled to convert circumference to diameter. The DBH tape is wrapped around the tree at 1.37 meters, or about at breast height. To get height, we use laser rangefinders. These find the height by measuring the distance to the tree at eye level, the distance to the bottom of the tree, and the distance to the top of the tree, and then use trigonometry to calculate the height. Height, and particularly DBH, is important for calculating tree biomass and carbon storage. Beginning in 2020, after the restoration of the Gamble's Mill Eco Corridor, we started an effort to tag all the trees there. The same methods are employed in the Eco Corridor for collecting data, except we also attach a tag to each tree that gives it a unique number. Tagging trees in addition to recording the species and measurement data allows us to keep track of individual trees to study tree growth and species composition over time. This is particularly important for quantifying the restoration's progress and goals, as we can compare species composition before and after the restoration, track growth of the planted trees, identify any invasive tree species, and learn how the ecosystem services provided by the trees in the Eco Corridor change over time. Once the data has been collected and checked for consistency, it is downloaded from ArcGIS Online and brought into the ArcPro mapping software. Here, we use a custom tool created in Python to update auxiliary information based on the species like family, native status, and common name. Additionally, the tool calculates the tree biomass and carbon content based off of the measurements available. If there's both a height and DBH measurement for a tree, then the biomass is calculated by multiplying the volume by a species-specific density. If there is no height available but we have the DBH, we can use equations developed from other forestry studies parameterized for each tree species. It's estimated that a tree is in general 45 to 50% carbon, so we multiply the biomass by 0.475 to get the carbon content. Finally, to estimate the amount of CO2 in a tree, we multiply the amount of carbon in the tree by the ratio of the weight of carbon in a molecule of CO2. Now that we have updated the points, we re-upload the layer to ArcGIS Online, where they are displayed in a dashboard. This dashboard shows a map of all the trees recorded and other useful information, like the total number of records, the percentage of native species, and the total amount of carbon stored by the trees on campus. Each point can be clicked on to pull up the species, height and DBH measurements, and other information. Additionally, you can filter trees by family, species, or DBH. For example, we can find the locations of the largest trees on campus by setting a minimum value for DBH. Perhaps you've noticed while walking to class signs on some of the trees around campus. Each sign has the species name, family, a fact about that tree, and a QR code that links to the dashboard. We hope that the signs will teach our community members a little bit about the trees around us and bring awareness to some of the benefits they bring. The Campus Tree Project has been a team effort that many students can say they've been a part of. We've collected over 2,000 tree records, including species, diameter at breast height, and height measurements. Using this information, we can estimate that the trees on campus store about 1 million kilograms of carbon. In the Eco Corridor, We are working to tag all the trees to track how the trees grow and how community compositions shift post-restoration. What better way is there to study the environment than to learn about and get involved in the ecosystem we interact with every day?